The central limit theorem forms the basis of the probability distribution. It is being widely used to infer something or make predictions from gathered data. I'll explain it in the next 5 minutes. In January 1901, astronomers discovered Ceres. However, after 6 weeks, no one can observe it again. Finding it was tricky, since 6 weeks' data is not enough to draw the orbit. As we know now, 6 weeks is only 2% of Ceres' period of revolution. Furthermore, people know that this 2 weeks data has all kinds of errors. To find Ceres again seems mission impossible, since we need to predict the orbit using insufficient data, but it won't stop a lot of people from trying. To find it, we need to calculate the orbit. To calculate the orbit, we need first to deal with the data with errors. Although scientists know that errors should be in a range and less possible for the big error. But what if we add up all kinds of errors together? What will happen? No one knows. At that time, 24-year-old Gauss had been experimenting with a mathematical method for which he would later become famous. Based on his assumption of error frequency, one formula fits the hypothesis that is later on known as the formula of normal distribution. When he applied this method to Ceres, he came up with a different prediction for its position than most other astronomers. And he was right. Based on Gauss' work, 9 years later, mathematician Laplace first proved the standard version of the central limit theorem, which states that even if a distribution is strongly non-normal, a sampling distribution of means will approximately normal for large sample size. The central limit theorem reveals the emerging mechanism of the normal distribution, also explains the ubiquity of the normal distribution. It makes it possible to use probabilities associated with the normal curve to answer the questions about the means of sufficient large samples. To fully appreciate this theorem, let's do some simulations using Python. I will create random samples of numbers from 1 to 100, each of size 500. Then I will run this simulation multiple times and see whether the sample means distribution resembles a normal distribution. Okay, this is what one samples group looks like. Now, let's repeat the sampling 1000 times, then plot the distribution of sample means. Here is what we get. As you can see, it is agreed well with the normal distribution. I have put a link to the code in the description. If you are interested, please find it and change the parameters to see what result you can get. 3 premises of the central limit theorem. The trials are independent, are identically distributed, and have finite variance. Can we use the normal distribution to describe the world population's income? Unfortunately, the answer is no. In 2010, it took 388 top billionaires to equal the wealth of the bottom half of the planet. And in 2014, this number changed to 85. In 2015, 62. In 2017, the 8 richest people own the same wealth as the poorest 50%. The reason is people's income is not independent. It depends on a lot of factors, such as which part he or she lives in. Can you explain the wisdom of the crowd? The idea that large groups of people are collectively smarter than the individual expert. Please leave a comment below. 2 takeaways. First, the central limit theorem states that the sampling distribution of the mean approaches a normal distribution as the sample size increases. Second, there are 3 premises of the central limit theorem. The trials are independent, identically distributed, and have finite variance. I'm always here at your service. See you in the next one.